I hope I'm audible and visible too. Okay, so we'll be sharing the link shortly for the quiz, for round one data challenge quiz. So I'll start after 2 minutes. Please let me know. I hope I'm audible. Please let me know once in the chat box. Okay, thank you. Thank you for confirmation. Very good morning to all of you. I will share the link in a while. Fine, so I guess we are good to start now. Yeah. So a very good morning and a warm welcome to Wits Delhi 2022. On behalf of Wits Delhi, I would like to thank all the speakers, participants, and other guests present for gracing the event. I would also like to thank our community partners, Henry Harben Education and Udva Foundation, for supporting this event. WIDS, Women in Data Science, is a global initiative by Stanford University that aims to educate and inspire data scientists worldwide. It also aims to support women in this field. I'm quickly going to take you through a video that will give you a glance about WIDS 2022.
Data-driven decision-making is at the heart of so much in the world right now. We're making decisions not just for us now, but for future generations as well.
The connection to data science is becoming more and more important to the work. The work has been going on for the last 25 years.
So what really drives us at WITS is that we want diversity at the decision table here. And women absolutely need to be there.
To me, a healthy data science community is one that embraces diversity.
We started WIDS with a conference at Stanford University in 2015 with three main goals that haven't really changed. First, to inspire women to join or stay in the field of data science. Second, to educate everyone by highlighting fantastic women and their technical work. And third, to support women around the world.
And wow, did we hit a nerve we didn't even know existed. Fast forward to 2022, and we have 200 regional events worldwide in more than 60 countries. And it just keeps growing year after year.
Last year, we were with all of you virtually. We had a 24-hour around the world event, which was very exciting. And so despite the pandemic, we got together and we created this global community. We had speakers from over 25 different countries, and it was wonderful.
And one silver lining in an otherwise tough year in 2021 is that attendees to WiDS regional events could be from anywhere in the world. We also saw really interesting collaborations, WiDS ambassadors coming together to host events in Africa, Saudi Arabia, Colombia, and Central and Eastern Europe.
One of the things I really love about WiDS is hosting the WiDS podcast. And we now have listeners from over 160 countries, which is just incredible, and many different guests. And I'm also really excited to announce that we'll soon have a co-host of the WiDS podcast, Cindy Orozco.
We also had amazing participation in the WiDS Datathon this year. Over 4,000 registrants in the Datathon from over 90 countries participating in a challenge related to climate change. And a big shout out to all the WiDS ambassadors who held workshops. We had over 40 workshops across the world.
I hope we also lift our heads above the horizon and think more than just about this moment in time, and think about the goals that we have for our young women and our young girls who'll be leading the next generation.
With the WiDS Education Outreach Program, which is focused on secondary schools, we've delivered materials to collaborators in over 50 countries around the world. We've had a great year despite all the challenges in the schools with COVID. We've had pilots everywhere from Covada, India, to New Haven, Connecticut, to a refugee camp in Jordan and beyond.
New last year were the WiDS workshops, where instructors provided dozens of workshops that were attended by thousands of attendees worldwide, online.
These WiDS initiatives would not be possible without the generous support from our sponsors, the global visionaries, the innovation leaders, and everyone at Stanford.
One thing we've been very excited about this last year is working on what we call the Wits Academy. We got interested in understanding better what the barriers were for young women and for minorities to enter this exciting field, and how we could possibly remove those barriers, and what sort of programs could we put in place with partners all over the world to help.
Our ultimate aim with WiDS is to increase the percentage of women in data science. Women across all domains and at all levels, from students to senior leaders, by the year 2030. And we call this 30 by 30. We believe 30% is a tipping point. That's when women truly believe that they are part of a group and they can contribute and have great impact. And we hope that you join us all in reaching this big goal.
For now, though, whether you're at Stanford or at one of the regional events worldwide or just in your living room, you are a part of the WiDS worldwide movement.
Welcome to WiDS!
Okay, so now I would like to give you a little about my background. I'm Dipti, I'm Wits Ambassador 2022. I'm graduate in Information Science and postgraduate in Data Science from Wits Academy. I'm working with NatWest Group in Big Data domain. Sorry, I guess there was some kind of glitch. Yeah, my area of interest in technology includes data science for social good to improve society and machine learning algorithms. So without further delay, we are quickly going to start our round one, which is a data challenge. I'm quickly going to share the link. Good luck to all of you. So here is the link. So this is the round one. It's a quiz, and the link has been already shared in the chat box. Let me know if you are facing any issue. And the same link has been posted on Unstop as well. You'll be given half an hour time for completing this link, for completing this quiz. hope quiz is going good for you all. So we'll be closing the quiz at 11:15. So we have another 5 minutes. Okay, so we are done with the round one. That was the quiz round of Data Challenge 2. We'll be announcing the winners at around 12:15. So I'm very excited to have you all here on Wits Delhi Day 1 event. So you'll get an opportunity to hear our wonderful speakers who are leading the way in data science. So we'll be starting our technical talk at 11:25 a.m. In addition, we have 3 rounds of data challenge, which will start, for which the first round we have already completed. That was the quiz round. And we are going to declare the winners for round one at 12:15. After that, we'll be starting with data challenge round 2. So we'll be hearing about classification techniques in data science from Pallavi Satsangi shortly. So our speaker has joined us. Welcome, Pallavi.
Hey, thanks, Dipti. How are you?
Pallavi, you're not audible.
Um, am I audible now?
No, still can't hear you.
That's
You
strange.
are on mute. Yes,
Yeah, is it okay?
yes,
All right.
perfect. Loud and clear.
Sure. So, how are you doing?
Okay, so Pallavi has joined with us. Welcome, Pallavi. So
Thank
I'll
you.
quickly introduce Pallavi. Like Pallavi is having around of 14 years of experience and expertise in retail, supply chain, payments, digital gaming, and banking domain as a project leader. She is currently working as a senior engagement manager with Quantify. As a part of her role, Pallavi is responsible for customer success and program management of AI ML engagements. She has deep expertise in artificial intelligence and machine learning, and her previous experiences include running large programs in driving delivery excellence and standardization across AI ML engagements. So I welcome you, Pallavi, in our WITS Delhi 2022 event. So
Thank you.
Pallavi is going to talk about classification techniques in data science. Yeah, so over to you, Pallavi.
All right. Hey, thanks a lot, Dipti. I'm audible now?
Can't.
Yeah.
Okay, yeah, you're audible.
All right. Okay. So, thank you so much for the introduction. And just to add on to what I do currently is I work as a senior engagement manager with Quantify, and I kind of manage good portfolio of the custom AI projects wherein we take in use cases from different domains for different clients, and we try to solve their problem statements by applying the machine learning or data science techniques. That being said, I will be speaking on an overview level on classification because classification and forecasting is something that it's quite close to my heart. That's because I've worked in a lot of projects taking these use cases. So let me just share my screen, and we can just walk through the session. Dipti, can you see the screen? Is it visible?
No,
Dipti,
Pallavi, I'm not able to see.
oh, that's strange. Okay, let me just share it again.
You need to just add it to the stream. I mean, at the down, you might be getting the option to share.
Yeah, that's what I've done. I've just done a share screen, and I'm sharing the entire window actually. Mm, yeah, it's not able to access the screen, it says. I'm not sure. Hang on, let me just try that out.
No, Pallavi
Dipti, I'm
still
just trying
can't
to add. Yeah, I'm just trying to add the
see the screen.
screen here so that it'll be easy to share. Yeah, so I think now it should be there. I can see my slides here. Not sure why it doesn't open.
Yeah, Pallavi, so I'm just going to share the screen.
Sure.
Let me know once it's visible. Is it visible to you?
Yeah, it is.
Okay.
Sure. So you can just move on to the next slide. Are you able to move to the next slide?
Yes, Pallavi, you can start.
All right. So the agenda that we will go ahead with today is first to understand what classification means in data science or machine learning, the main terminologies that are used in classification, what are the different classification algorithms, their evaluation strategies, and which algorithm to use when. So to do that, let me just give you a quick overview as to in which bracket does classification falls into place. We know that we have rather three types of learning, which is a supervised, unsupervised, and reinforcement learning. And if Dipti, can you just go ahead in the slides, because I'm not able to see the next one. The next slide. All right, till when DP does that. So classification falls under supervised learning, wherein we know that the given set of data, its related target values or the labels are present. So if you can see the picture, you will know that supervised is something that I have a set of data and I know exactly what that data means to me. Whereas in unsupervised learning, I just have a chunk of data and I need to find out what patterns and what kind of similarities or dissimilarities that the data has on. So that being said, when I say talk about classification, it basically falls under the supervised bracket, that is the left side, wherein for example, say I have a set of record which has apples and oranges, and I have got different rows for me to identify this fruit, and my target value here would be whether this particular row belongs to an apple or it belongs to say an orange. And that is where it's a supervision, wherein a set of labels are already provided to the data. The model learns basis those the patterns and its related labels, and then it will be able to predict on the next set of data. So this is what basically classification does. So if you can see the next slide, we can you can see that we have supervised and unsupervised. And under supervised, there are two main algorithms that we talk about. That is the classification and the regression part of it. And so for today, we will be sticking on to the classification module. Dipti, you can move to the slide 5. All right. So like how I was mentioning, classification, it's basically a supervised learning technique, and it helps the model and us to identify which category the new data observation will fall into. And we basically use classification when we have a categorical form of a data. When I say categorical, it is in terms of 1, 0, yes, no, spam, not spam, fraud, not fraud, this kind of a data, so that my algorithm will classify my new data set into one of this bracket. It could either result in a value like 1 or a 0, or if I have, say, email related data, it is going to tell me whether it is going to be a spam or not a spam, and things like that. So this is what basically the classification algorithm does. Now, on a real-time scenarios, where can I use my classification? It is used across all the domains. It could be in terms of retail, wherein I have in my retail, I can do wherein I want to understand my consumer behavior, whether my consumer is going to come back or is not going to come back. Is it a new customer or is it going to be an existing customer? Then I can do a lot of document classification using my classification techniques. Image classification is one big area where we predominantly use different forms of classification. Along with that, in our banking domains, you can say our credit related to our credit cards, or loan, whether I'm supposed to approve the loan to the customer or not, what kind of a customer it is. In all the scenarios, classification comes into a lot of it's advantages for us to use classification. Moving on to the next one, what kind of terminologies, when we talk about classification, what are the usual jargons that we come across? We all know, we speak about when we say classification, first is, what kind of classification? Now it could be a binary classification, it could be a multi-classification, multi-label classification. Along with that, we talk a lot about features. Features are nothing but, in layman terms, it is my columns of, say I have got a table which has all my data. So my features is nothing but my columns, which we call as features or attributes. Then what else do we come across? We come across something called as training of the data, the testing of the data, and specifically with respect to classification, we hear a lot about something called as accuracy, precision, recall, confusion matrix. These are the ones. We will cover all of this at an overview level in the later slides. Dipti, you can move on to the next slide. Slide number 8. So coming to different set of classification algorithm, I have covered the ones which are predominantly used. We start off with a logistic regression decision tree. Then we have something called as a KNN classification. We have a naive Bayes algorithm. We call it SVM, support vector machine, random forest. And last but not the least would be your neural nets, which is your artificial neural network, which also can be used for our classifications. So that being said, we can start off with the first algorithm, the most known algorithm, which is the logistic regression. All right, so in the logistic regression, it is one of the most popular machine learning algorithm. And as we have already discussed, because it's a classification, it's used to predicting a categorical variable. Dipti, can you move to slide number 9? Yes, that's fine. So as you can see here, this is my basic S-shape graph that we always use when it comes to logistic. And this is my threshold. When I say my threshold, this would be like my boundary sort of a line, wherein anything above that, I am going to say it is 1. That means it's going to predict one set of my category when it is above 0.5. And when it is below 0.5, it is going to set, predict me the other sort of a category. Now, if I say, for example, I am taking that spam, if my mail is identified as a spam, I'm going to give it a value 1. And if it is not a spam, it is going to be 0. Now, my threshold, I'm giving it as 0.5. This threshold can also be given on different levels. It could start from 0.1 to 0.9. It depends upon the use case that we are doing. I'll not get into that detail, but for now, let's stick on to the 0.5 as a threshold. Now, if I want, when I run my model and I give my threshold as 0.5, any value basis my objective function that comes out is greater than 0.5, then I tag it as that it's a spam email. Otherwise, I put it as it's a not kind of a spam kind of an email. So that's what basically logistic regression does. It has its own strengths and weakness. When it comes to the strength of the logistic regression, we know that it's a probabilistic sort of algorithm. So it gives us very good probabilistic interpretation. It's quite fast, especially in terms when we want to find out the unknown records. Logistic regressions actually works good. They are very less susceptible to overfitting, wherein, when we talk about overfitting, we all know that when my model gets trained, the model behaves very good on the training data. But when I throw an unknown data towards my model, it goes haywire. It doesn't give me good results. And that's what we in machine learning terms, we call it as overfitting. But coming to logistic regression, it's quite susceptible to, it's very, very less susceptible to overfitting. And in case overfitting happens, we can use sort of regularization and some sort of techniques that we can do wherein we can overcome this overfitting problem. Now, that being said, we also have a couple of weak areas of logistic regression. The main point being that when I'm giving a data for logistic regression to, kind of train on, there should not be any form of multicollinearity. When I say multicollinearity, I might have 4-5 different features. Now, each of these features, there should not be any strong relationship among these features. If these features are strongly correlated among each other, then my logistic regression kind of doesn't give the desired, accuracy that we are looking for. That's what logistic regression does. Now, coming to where we can use logistic regression, we can use it in various places, predominantly in consumer behavior. Like I said, then we have spam detection, fraud detection, text classification, so on and so forth. This is about logistic regression. And next, very famous and very widely used algorithm that we have is the decision tree. When I say decision tree, of course, it is in the form of a tree structure and hence the name. If you can see the pic here, you can make it out that we have basically two forms of nodes here. We have a root node, which is the start of the node, and then anything in internal wise, wherever we have nodes, it is called as internal nodes. And the last but not the least, we have the leaf nodes, that is where the tree sort of ends. It doesn't kind of iterate more beyond that. So these are the three main features. So decision tree, it's kind of very easy in terms of implementation and more in terms of visualization. We can see when we come in the form of a T structure, for example, here, we have something like a body temperature, which can be warm or cold. Now, I know when it is cold, then it is not a mammal, and my entire, observation ends here. Now, if my body temperature is warm, then I can have another condition attached to it. Whether it gives birth or not is my second node. And if it gives birth, it is mammal. If it doesn't give birth, it is not mammals. So this is what, on a broader note, this decision tree does. Now, how does this decision tree come to know as to which node at what point of time it is supposed to populate with? This is where we come in terms with techniques called as entropy, Gini index, and information gain. And basis that is what my nodes are kind of shortlisted by the decision tree. Coming to its strength and the weakness of decision tree, like I said, it's very good in terms of visualization, and the computation that is required is quite low for decision tree. And the rules, when I say the rules, it is nothing but the nodes and the leaves, the structure in which the nodes and the leaves are created. These are the rules. When it, which side it has to go. Should it go to the left node or to the right node? Things like that. It generates very understandable rules. So that is one of the very good strengths of decision tree. Now, the weakness, any real-time scenarios, when you apply decision tree, almost 99 or rather more than 99% of the times, we end up in overfitting the model, because that is the basis of decision tree. It has very less bias, very less assumptions. It tries to split each and every set of data at every node level, that it makes the entire model kind of overfitted. And that's the reason it becomes expensive for us when the data is large and the decision tree gets into an overfitting model. It becomes expensive for us to prune them. When we talk about prune them, we can sort of cut down what depth the decision tree goes or how many leaf level it has to reach out to. We have a couple of techniques for ensuring that overfitting doesn't happen, but that again is an expensive process for us. So this would be one of the weakness of the decision trees. Now, moving on to the next sort of algorithm that we have for classification is the KNN. This is again one of the most popular and the simplest machine learning algorithm that we have. When we say about K nearest, KNN stands for K nearest neighbors, and K is nothing but the number of neighbors that we are trying to get associated with. When I say nearest neighbor, it is as simple as that. I have a data point and I want to understand this data point belongs to, say, neighbor A or neighbor B. All I do is I try to find the distance of my point to the nearest of the neighbors of one category and the distance with the neighbors of the other category. Now, wherever my distance is less, that means my similarity is more, my new data point falls into that bracket. So if you can see this particular figure here, we have shown the blue one is a new data point, and post KNN, we come to know that the distance of the blue with respect to the green points are very near, and that's the reason we classify this new blue color point as being as part of the red group. So this is what the k-nearest algorithm does. Coming to its strength, it is very, very simple to implement. And even if the data has a lot of noise, KNN to a certain level is able to kind of become robust to the noisy training data. And if you have large training data, KNN still performs quite good when when the training data is large. Now, coming to its disadvantages, or rather the weakness part of the KNN, it is that when we talk about KNN, K is the number of neighbors, right? For us, sometimes to find out what is the ideal value of K, it gets complex in time. And sometimes the computational cost, it becomes quite high. Let's say I have a large number of data points. Now I'll have to, if I'm assigning a K value on a quite higher level, for me to computing the distance of that new data point with the rest of the data points, it sometimes involves a lot of computation power. So that kind of becomes one of the weak points of KNN. But that being said, it is if you have a very straightforward or simple use case of a categorical variable that needs to be classified, KNN is one good shot to go for. Where exactly KNNs are used for detecting outliers, like I said, outliers are those rare data points, which are very, very, very away from the mean. And how does KNN help us out is because when we're trying to find the distance between my data point to the outlier, which is, very far off, obviously my distance is too huge. I immediately come to know, no, this is something like an outlier kind of a point. So this is where KNN is predominantly or vastly used in detecting outliers, and many times to find out the similar documents. Like I have, say, 100 similar documents, 100 documents. Now I want to find the similarity between them. This is again the distance based. So that's the reason KNN becomes a classic use case for us to use. It is also the base for the recommendation engine. Of course, we have a couple of more sophisticated algorithms that are in place, but the baseline wherein we would like to start off with is again, the distance based. So for the recommendation part systems also, to a certain extent, we can use KNN. Now, the next use case that we have is Naive-Bayes algorithm. From the picture, you can see that we have something like a probability of dog versus cat into probability of cat and things like that. So the first thing that comes to our mind is that this is a probabilistic classifier. That is because it predicts basis the probability of an object. The higher the probability value that we get, the higher chance of predicting that this particular object belongs to so and so category. In the internal, actually, the Naive-Bayes, it follows the Bayes theorem of probability, and that's the reason we have named it as Bayes. And naive is why we call it is because this particular algorithm, it gives equal importance to all the features, wherein in reality it might not be the case. There could be some features which are of more important to us when compared to rest of the features, but knives being knife, it gives the same importance to all the features. In spite of that, if you check out in real-time scenarios, many times it kind of works well. It works well, especially for text classification, again for spam filter, for sentiment analysis. In all these areas, the Naive-Bayes, it actually works wonders. It does well. Coming to its strength and weakness again, one of its strengths is it's very fast. It's for me to train the model on Naive-Bayes is quite fast. And other than just working on a binary sort of a classification, we can also use it for multi-class classifications as well. Now, coming to the weakness part of it, I already explained as to why it is called knife. because it gives equal importance, and that actually might not be the case for my specific use case that I'm working on, and that would become like my weak point in using the naive Bayes. So that is one of the weak areas of this particular algorithm. Moving on, next is the algorithm that is called as support vector machine, and this is something that can be used for your regression as well as classification, but it's primarily used mostly for the classification problems, because again we have like a decision boundary here, and we ensure that anything that falls on one side of the boundary goes to one category and another side of the boundary goes to the another category. So that's the reason we end up using it more in terms of a classification use case. But what is the goal of SVM? If I have to talk about it's or when my model is implementing a SVM algorithm, what exactly it's trying to do? It's trying to find out that best decision boundary that it can form, wherein it can correctly be able to dissect between the two sorts of datas that I have. Basically, the best decision line we call as the hyperplane in the technical terms. And if you can see the figure, we also have something called as with along with the decision boundary, we have two other dotted lines. Now these are, I can say, the max gap or the max distance, because I just cannot have just one line or any other point which are relatively little away from my main line. What do I do with those points? Do I just ignore them? Do I discard them? Do I kind of put them in a default bucket, or what do I do? So for that reason, we have said, okay, this is my decision boundary, but my decision boundary's capability can extend till till some part of the distance, and that distance is nothing but the other two dotted lines that you see. So our whole use case centers around the best decision boundary that we can create, and also the best sort of the distance and the next level of hyperplane that we can kind of support vectors, or what we call them, is what sort of a support vectors that we can kind of design on. So this is what SVM helps us out with. This is very good in terms when we have, say, an unstructured or a semi-structured sort of a data. It could be in terms of text or images. And when I have a high dimensional data, actually support vector machine, they work well. But that being said, when I talk about its weakness, the computational time also increases, because when I'm working on large data sets, for it to find out the best decision boundary and reduce the cost function, all of this takes a lot of time. And other than that, one of the thing would be the fine tuning of the the boundary line, and what sort of hyperparameters do I use for it to to kind of fine tune that particular line. That sometimes becomes difficult or complex, and that's the reason this is taken as one of the peak areas of the SVM. SVMs, again, we use them predominantly in medical field, wherein for cancer diagnostic, for your handwriting recognitions, and also almost all the places where ANNs are used. Now I'll say what ANNs are in the coming slides, but this is pretty much what SVM does. Moving on to the next algorithm, this is the random forest. Again, we spoke about decision tree. We know it is a tree. Now we're talking about a forest. So by default, we know that it is nothing but a group of decision trees, right? A group of trees sort of a thing. And that is nothing but random forest. In terms of machine learning or data science, we call it as an ensemble method of classification, wherein I group in a number of decision trees, and each decision tree is going to get modeled, is going to get run, and the best results among all the decision tree is taken in the form of a voting, or it could be in the form of I'll average out all the 3 decision trees results and then give the final result. Now, what all weaknesses that we found in decision tree that can be overcome with a random forest, starting off with the overfitting issues that we used to have in decision tree. That is something that is taken care of by random forest, because in this case, right, we have different forms of decision trees that we do, and then we merge all the decision trees results and then finally get the final result out of it. So that's the reason it performs better. It most of the time it performs better than the decision tree. Now again, it depends from use case to use case. If there's a quite a simple use case with a fairly normal data, then you can as well go for the decision tree. Else you can prefer something like this ensemble technique, which is the random forest. When I talk about the strengths, of course, the first thing is it's quite fast. It helps to overcome overfitting the issue. And they also deal well when the data is imbalanced or when I have a lot of missing data. Now, when I have a lot of missing data, random forest, when it is running internal with its level of decision trees, many times all these null values are taken and put in as one part of the node in one of the default nodes as and but they are considered as values. So that's the reason it kind of works well when even if I have the missing data. But when the data becomes too noisy, then again the random forest also might get into the overfitting issues. So that becomes one of its weak areas. Along with that, say the importance that the random forest gives to each of the decision tree and the weights associated with that, it again becomes cumbersome for us to kind of tune it or come to that particular conclusion that this weights is something that's going to give us the best accuracy kind of a form. So that becomes one of the weakness for the random forest. Random forest is heavily used in credit card fraud detection, in your customer segmentation, for predicting the loan defaulters for your banking applications. In your healthcare domain, it's again whether we're predicting whether the person might get into diabetes or not get into diabetes, and scenarios like this, random forest is used a lot. Moving on to the last algorithm. Now, all of the above algorithms we all know is part of the data science machine learning part of it, but this particular one, that is the artificial neural networks, it falls under the bracket of neural networks. Now, when we talk about neural networks, why do we need a neural network classification, right? When we already have so many other classifications in place. That is because in real time, the data is always not very linear. It's not very linear in nature at all. And that's a reason. And the data is quite huge. You end up getting 10 years, 15 years worth of data. So for scenarios like that, your neural networks comes into picture because it is, kind of made in such a way to handle large data, it has large computation power, and when the data is not linear, the kind of functions that we use inside the ANN and all of that support, wherein when the data is not linear, it can still handle the data and it can still give us the desired output. So under ANN also we have something called as a classification ANN. It's basically an artificial neural network which can be, the layers can be made in such a way that it's going to classify and give us the results. Here, one of the other technique, like I said, would be that it does not even work well on, categorical, but it works well on now numerical as well. Whereas when you consider decision tree, it is very good for categorical. But when it comes to continuous variable, the decision tree doesn't perform well at all. So this becomes one of the advantages or strong points for our ANN. So when we go to its strength and weakness, of late we have so much with respect to videos and images, related data, that in real time it gets churned in various different domains. So for us, any form of classification that involves, say, an audio, a text, a video, or an image, ANNs actually kind of work well because there's something called as feed forward and a back propagation kind of techniques that are there in ANN, which actually helps us out to get good results when it comes to the classification. Now coming to the weakness part of it, see, I'm using large data, I'm using large non-linear data, and I'm going to introduce a lot of hidden layers and different types of activation functions, optimization functions. All of this are computationally intensive to train. So when you end up doing neural nets, you more or less or almost all the time you end up using a GPU. So all of this, your infrastructure wise also, it will be little intensive. So that is something that we need to take a call before we start working on ANNs. So that becomes more or less like a weakness part to it, wherein there's a lot of infrastructure investment, computationally it's intensive, and there are a lot of parameters, a lot of hyperparameters that we need to tune when it comes to ANN. The knowledge of what those hyperparameters do and how to tune them, and when we tune them, what happens, is something that if you know them, you can do it well. But if you don't know them, then your model is definitely not going to give you good results at all. So again, like I said, ANN's use cases where in real time we are used is highly. It's used in your image classifications, in your text classifications. In medical, you have a lot of sort of medical diagnosis. These are critical use cases for us, and ANN works beautifully in all of these scenarios. So this is pretty much on the different forms of algorithms that we have. Dipti, should I continue, or do you want me to take a pause? Can you hear me?
Okay, so let me just see. Do we have any question? Okay, so let me just see. Do we have any question? Pallavi, I think you can continue. Maybe we can take up the questions later on.
Sure, I'll do that. Quick. So moving to the next agenda that we have, once say any of the models that I've worked on is created. Now, how do I evaluate my model? How do I know my model is good or bad, or what are the techniques that I go forward for evaluating my model? And that becomes a topic for us called as the classifier evaluation. Specific to my classification, the four majority ones that I used are here, which is called as cross-validation. Then we have something called as a holdout. Then we have something called as an entire classification report. And last but not the least, ROC and AUC, which is very, very important when it comes to classification. Now, when I talk about cross-validation, say in real-time scenario, you have a use case wherein you have to classify let's say target A and target B, but I do not have that range of data. But how do I ensure, how do I test it out to ensure that my model has actually worked well? So when I have a limited set of data or a smaller, training set, what I do is I implement something called as cross-validation. Now, if you see here, I have put in 5 different rows here, wherein the gray cells indicate the training data and the red one as a test data. Now, what I do is first time I take, say I have 5, so maybe 80%. I have taken 80% of the training data and I've left 20% for the test. I run my model on that 80% data and then test it against the 20% of the data. Then I shuffle the data again. Now, if you see row number 2, this time I take 20% of a separate test data. It is from the same set of the data set, but every time my kind of window keeps moving around. I take 20% of the test, take the 80% of the rest of the data and kind of train it and test it against this test data. So what this helps me out in giving me a better performance or better accuracy for my model, because I'm trying to, take in all the different patterns from my data at all different levels and train them, and then check it with the test data across it. So this is one of the predominantly used technique when we have, say, a limited amount of data set that is available with us. The next one is the holdout, which we all know is nothing but, we all say train data, test data, train data, test data. When I talk about my holdout, whenever a data is given to me, depending on the size of my data, the usual split that we do is an 80-20%, assuming that I've got a good amount of data. Or there are times when I go with a 70-30 or even a 60-40. And when I say holdout, my 80% of the training data is something that I feed to the model and make it learn, and 20% is what I hold it to myself, and that becomes my holdout data, wherein once my model is ready, I pass this holdout data to the model to actually see how the model is performing. So that is pretty much about holdout. Now this particular technique, that is a report, the classification report that we were talking about. You can move to the next slide, Dipti. Yeah. Now this is just related to classification now. And this is the basis, this is the, what I can say, like the holy grail kind of a thing for my classification, wherein anytime I perform a classification, the left side, the one that you see, is called as my confusion matrix, which actually tells me what were the truly positive data, actual versus predicted, what was the false data. Now this is into 4 types that you can see. You can have a true positive, you can have a true negative, you can have a false positive, or you can have a false negative. And you can also see in the figure around, we have 4 values associated with it, which is the precision, accuracy, specificity, sensitivity, and the predictive value. Now basis my each and every use case, one of this particular metric becomes useful for me. uh, Let me give an example. Say I am trying to predict if a person has cancer or not. Now, for me, if a person gets cancer, means, and if I'm falsely telling it that the person has got cancer, or my model has falsely predicted that the person has got cancer, it becomes a false positive, right? Falsely, I'm saying that the person has got cancer. Now, that person would be sent for for his chemo. Now, that could end in a disaster. So, I need to take in a metric which actually gives me a proper and a correct, accurate result when it comes to my positives that are being treated. So scenarios like that, I will use my precision. Now I'll take another example. Say I'm testing people who have COVID as an example. Now, if I falsely, again, if I say a person has COVID and I say he does not has COVID, then it becomes like a false negative. Falsely I'm giving a negative report. Now for false negative, I will be using another metric here, which will actually give me a value wherein my false negatives has to be as minimum as possible. Because falsely I give him a negative report wherein the person actually has COVID and the person goes out and he's kind of spreading it across. So classification, the tricky part comes into 2 in the end. When the data is highly imbalanced, wherein I have, say, 2 labels of data. Say I have 100 records, out of which 90 patients have, 90 patient records are wherein they don't have COVID, and 10 records I have which they have COVID. Now, my accuracy of the model could be good, but if I have to find out of those 10 patients among the 100 which are actually have COVID, how much percentage is my model accurately finding out? So these are the metrics that help me out. So that's the reason when we do a classification, for us, having these metrics in place becomes very, very important. And that again depends from use case to use case as to what we are solving. Is false positive important to us, or true negative important to us? Things like that is where we come up with this formula and work on these formulas. So this is one of the most important report that we follow when we perform classification algorithms. Now, last but not the least is the ROC AUC curve, which we hear a lot about. This is nothing but, in a simple terms, if I have to put, the ROC, the green line that you're seeing, is the graph between my true positive rate and false positive rate. Now, I'll be having different thresholds, right? Like we discussed in logistic regression, wherein, say, I'm giving a threshold of 0.5, and anything above 0.5, say the person has COVID, and anything less than 0.5, the person does not has COVID. Now I can also tweak my threshold and make it, say, come down to 0.3. And now I say that anything less than 0.3, they don't have COVID, and anything above threshold of 0.3 have COVID. Like this, I can have different thresholds. Now, when I combine all the thresholds, all the true positives and false positives that come out of it, I draw my ROC curve. Now, under this curve comes my something called as area under the curve, that is the AUC, actually, AUC. And the one which covers me, gives me the highest value, it is that range that I'm going to pick up. So for me to, end of the day, understand what is the relationship between true positive rate, false positive rates at different thresholds, my ROC and my AUC comes into picture there. So I think this was these are the different evaluation that we can take into consideration when we are trying to use a classification algorithm. Now, the next question comes, I have got so many algorithms, which do I use and when do I use what kind of a thing? Now, again, this depends upon, what kind of a use case you're working on, what kind of a client you're working on, what is the duration of your project, how is your data? Then, that's what it's been put here, what does a business want, what kind of a data that they're willing to share, what is the size of the data, and what is your infrastructure? Do you have that enough infrastructure wherein you have the GPUs to run in place, wherein if there's computational intensive work that needs to be done, which can still be taken up? And does the data has a lot number of features? Is the data linear or not linear, and things like that? So considering all of this, in real time scenarios, you don't just end up just working on one decision tree and tune it, or maybe you just work on one KNN or one ANN. Nothing of that. You don't just work on one. In real time scenarios, basis these features, we bring it down, say, to 3 or 4 different algorithms. We run all these 4 algorithms, try to tweak it up, give some give deviations in the data, and then check which of this algorithm is consistently performing well, and that becomes our final model that we choose. So this is how we end up knowing which algorithm to use at what point of time. So if I have to bring it down to summary, the summary is that we have the data. Then out of the huge chunk of data, you select the data which you feel is going to add value. Then you pre-process the data, you clean it up, your null values, your duplicate values, your extreme values, your outliers, or all of those. You clean that up. Then you end up transforming the data, wherein when you see there's huge range for one data. Say, for example, I have a number of customers for for a store, that is one of my attribute. Now, for one day, I might have only 10 customers who have gone in, and then a weekend comes and I have 1,000 customers gone in. Now, my data for that attribute has 10, 1, and then it has 1,000, 2,000. Now, the range of the data is, quite drastic. So we need to transform that data. We need to bring it into, kind of squish it in such a form that it kind of normalizes. So we have techniques like, min-max, scalar, and things like that we use to transform the data. Once the data is transformed, then you take the data, you put it into the model and train the model. Then you evaluate the model using all the techniques that we have spoken about, and finally you end up getting the actual knowledge, or rather the actual success metric what the business is looking for. So this is pretty much what you kind of do when it comes for classification. That's all, I think. I think that's the end of the session, Dipti. So if anybody has any questions, actually, they can ask now. So if anybody has any questions, actually, they can ask now.
Yeah, Pallavi.
So if anybody has any questions, actually, they can ask.
Yes, Pallavi.
So if anybody has any questions, actually, they can ask.
Yes, Pallavi. Yeah, we have a question. What are the normalization requirements for classification techniques?
Okay.
Where min-max scalars are used by default.
All right. Okay. See, like I explained the example, this say a real-time example only. I have, say, a column wherein the column captures the number of customers on a, say, daily basis. So this is in my entire data set, this is one particular column that I have. Now, the values that you see there, it can be 1, or in fact, if you want to bifurcate more, say I have an hourly data. I have a store X, and in that store on an hourly basis, how many customers are getting inside the store. Now I have a data related to that. Now, say at 9 in the morning, I had just one customer who came in. At 10 in the morning, say I have 2 customers. Maybe by 12 noon, the number of customers increased. This is how I'm going to capture the data. Say on a weekend or Saturday, a sales is going on in the store, and at 11 in the morning, I can have close to 500 customers who have gotten. Now, when I see my data, the column, that particular attribute has values like 1. There could also be 0. Say I take 11:30 in the night. 11:30 in the night, there's no customer has walked in, so the value could be 0. So now my value ranges can be from 0 to say 500. Now, when I put it to my model, for my model, it looks strange, right? Because there are values as low as 0 and to as high as 500. So what we do is we try to normalize the data. And when we try to normalize the data, we try to kind of squish the entire data into, say, a readable form. And for that, we basically have two techniques, which I was talking about, which is standardization and normalization is what we use. I think standardization uses something in terms of z-score, and min-max has its own formula, wherein basis using that formula, you can kind of bring down or shrink the range of the values that you have for your data, and that will normalize the data so that the model will not get into shock when it sees that high range of data. Right now it's all kind of clues for the model to kind of understand and train on. Yeah, Dipti, I hope I've answered the question.
Okay, that was really a good explanation.
I hope I've answered the question.
Okay, that was really. Yeah, so I'm just checking the chat if we have anything else. Yeah, I got a query like, can you please share the slides? Yeah, Pallavi.
They can reach out to me. That's fine. I'll try to share it with them. They can just reach out to me.
Okay, we'll share it.
Yeah. I think in the end, I've given my Gmail ID and.
Yes, we have another question. In our feature set, is mixture of numeric, ordinal, and nominal values. Which technique we should use for classification?
All right. So if you have, say, a nominal or an ordinal value, let's start off with, say I have an ordinal value. I can kind of convert that using my, your one hot encoding or your dummy values, wherein, my entire, each and every row now will be recognized. But in real life, or real life implementation that I have seen, if you have enough data, I think you should go with ANNs. They really work wonderful when there is a mixture of all sort of data types that you have, be it numeric, continuous, discrete, nominal, ordinal. Your ANNs actually work well, so you can try going with that. And in case if your ordinal, nominal values, say if I say ordinal, I have only 4 different, or rather I can say 3 different ordinals. Maybe I have small, medium, and big as an ordinal. In that case, you can always go ahead, create your convert your categorical into your dummy values, or use your one hot encoding technique, whichever works for you, because the your dimensions won't increase a lot, and then pick up whichever algorithm you want to. But if you have huge number of values within your nominal, ordinal, discrete, and continuous, then I feel you should just go for your ANNs. They work well. I think I answered the question.
Yeah, so I hope you got your answer, Atul. Fine, so if no question, yeah. So like Pallavi, that was really an informative session about different classification techniques. And you explained it so well, taking all the techniques, discussing about the strength, weaknesses, and also taking all the use cases of all the techniques. That was really wonderful. Lots of learning were involved. So that was really great. Yeah.
Thanks a lot, Dipti. I think
Thank you so
I
much for being
sure.
with us.
Thank you. I think you can share my LinkedIn link and my Gmail. If anybody wants to reach out to me, they can. It could be anything in terms of they want more inputs on data science, or any other suggestions on how to move into data science or things like that. Me, I have done that personally, so I know the path, how to take it, and how to move into a complete AIML sort of a field. So they can feel free to reach out to me. I think both my email ID and LinkedIn link I have given in the slide. So maybe you can just flash it once on the screen, and they can get it.
Yeah, sure, Pallavi. It's on the first slide.
It's the last
Yes.
slide. You didn't get that. All right. Then that's okay. I think you can just share it with them later on. I'll just put it across to you. You can share it with them. I've just put it in the chat.
Yeah, sure. I'll share.
I've just put it in the chat.
Yeah, so I'm just going. I will share it with all the
Sure.
participants. If at all they want to reach out related to any queries, any concern, they can reach you out and they can connect on your LinkedIn as well.
Sure. Great. Thank you.
Want to reach out related to So thank you so much, Pallavi.
All right. Yeah. Thank you.
Thank
Thanks for
you.
having me. And
Bye bye.
yeah, bye. Thanks.
Hi, Puja.
Hi,
I hope I'm
Deepti.
audible.
Can you hear me?
Okay, so we have Puja with us. So just give me a moment, facing a little glitch.
Yeah, sure.
Yeah, I hope I'm audible. So we have Puja with us. Puja Gupta is currently handling a leading role as a product owner management leadership analyst are
Yeah, I
some
hope
of
I'm
her
audible.
duties
So
as
we
the
have Puja.
team appreciates working with her. She has completed her bachelor's in computer science from Delhi University. She has a keen interest in the education and finance sector. She believes that to change the world, education is of utmost importance. In her college time, she was an active member of an NGO and continued to do social activities for betterment of the society. So, Pooja, I welcome you.
Thank you so much, Deepti, for the nice opportunity to have me on this platform. I'm really obliged. All right, guys. So yes, with Deepti, we have and WIDS, we have conducted this data challenge for you all, and we received like 800 applications. Um, from entire India for this competition. And in the round one, we have selected like 25 candidates to go into the round two, which we will be starting at 3 or 3:15. Like Deepti will share with you the time. And to announce the results, I would be sharing with you the mail. You may check out your email address just now. We have sent you the mail. I can also, Deepti, can we share on chat also like the name of the people? Okay, all right. So I just had mentioned all the selected participants on the chat also. Maybe you guys would be able to say it.
Yes, sure, Pooja.
Um, okay, I have shared it on chat. Could you check whether it has been shared with participants or not?
No, I can't see in the chat.
You can see. Okay, all right. Hold on.
Okay, yeah, just give me a minute.
You can see.
Yeah, now got it. Yeah.
Okay, cool. Also I have. Okay, cool. I also mentioned the same on this also. Perfect. You also shared the cool. So Deepti, could you please let us know like when can we have the round two?
Yeah, can we start it like after, I mean, after this technical talk?
Yep, sure. So guys, what's in round two for you all is that in round two we would be sharing with you an Excel data set with certain questions to it. What you need to do is you need to find the answers and consolidate all of them in a PDF and send it on our email address, that is pooja@henryhaven.com, and I'll deeptik24 at gmail.com. I'll share with you both on the email itself, like in the instructions, what needs to be done. And after that, we would be, screening out almost like 10 students or 10 teams. And then we would be having round three with those 10 teams. The time allocated for this is almost 45 minutes. So the moment you receive an email, we would be counting 45 minutes from then. And the time will start at 2 p.m. for all of you guys. 2 to 2:45 would be the time for round two. If you have any question, you can shoot out to me those questions on my email address. And yes, that is it from me for now, Deepti.
Uh, yeah. Okay, Puja, fine. So after this session, we'll be just doing it. We'll be starting the round two.
Cool. Perfect. Awesome.
Okay, so thank you for being with us, Puja. Please join us. After some time, so that we can start with the round two
Yeah,
of
sure.
data challenge.
Definitely. Definitely. Okay, Deepti. So I'm going backstage.
Thank you. Yeah, sure. Thank you. So I'm really glad that we have our next speaker, Dr. Nidhi Arora. I welcome you in Wits 2022 Delhi event. So let me quickly take you all through Dr. Nidhi's in, profile. Dr. Nidhi holds a PhD in Information Science from INHA University, South Korea. She is an NLP enthusiast with experience in using deep learning and machine learning models to solve real world problems. She has worked as a skilled academic practitioner for nearly 8 years and has recently joined as a full time research scientist NLP in the conversational AI domain. She has 16 publications in various conferences and journals of national and international repute. She is currently working on building end to end deep learning models using transformations and prompting based NLP techniques to solve challenges of conversational AI space. I welcome you, Dr. Nidhi.
Thanks a lot, Deepti. It's my pleasure to come here and talk. Um, so thanks a lot. And um, how? So I how do we share the slides, Deepti?
You want to share your screen?
Right. Okay. Fantastic.
Okay. So at the down, you can just find the
No,
share option.
it's I'm just waiting. That share option is not.
Okay. If it's not there, you can
No,
just
it's coming disabled, so it's not enabled. So I can see
you can just
cancel and share.
okay. So in that scenario, can we do something like, can you please drop it in so that I'll just share it? Because I don't know how come
I
it's so
shared,
visible.
yes, I shared my slides with you just like 10 minutes ago.
Okay, just let me just have a check.
I think I can now. Let me know, what do you see on the screen?
Right now, I can't see.
Okay,
Maybe it takes a little time to come.
sure.
Yeah, I have added it. I hope it's visible. Please let me know once you can see.
I can see, but okay, I can see this it being shared now. So it would be easier if we can go through that with the stops, with the screen share, because then that way I can traverse the slides as and how I want.
Okay, so I have just added it. You can just check. You might be able to, go to the next slide. Please check once.
Deepti, I'll just disconnect and reconnect again. Okay.
Sure, sure, please.
Hi, Deepti. Can we see the slides now?
Yes, as soon as you have just shared, I have added it to the streaming. I hope it's visible.
It is visible, but I cannot go on to the next slide.
Okay, just give me a minute. Please allow me a minute. I'm just trying to check it out.
I think there is, I don't know why, there is some lag as well. I can see it just spinning round and round, waiting for it to
So I
connect.
have already shared. Okay, maybe the could be possible the network issue.
But my voice and video is coming all right, right?
Yeah, I can hear you properly and you're audible as well. You're visible as well, sorry. Yeah. Now, can you see that next slide option at your end?
Yes, now I can. Like, so there are navigation buttons I can traverse. Yeah. I'll skip the first slide. I wanted to start with this Sanskrit
Yeah.
shlok actually. It's really nice and wanted to congratulate all the women, but
Yeah.
because of all this technical glitch and all. So, thanks, Deepti. Thanks for inviting me for this talk. And the audience is already being told. So, this is Dr. Nidhi Arora, and I currently work as a research scientist in the NLP domain with Interactions IVA. And Interactions is one of the best companies, and I'm really proud to be a part of the research team here. And I'll tell you two main important reasons for this. So Interactions is basically into the business of designing virtual assistants, and it came into this market in early 2004. So that's when these chatbots were not so popular, and there were very few organizations who had commercially successful intelligent virtual assistants into the market. And Interactions came into the market and came introduced with a patented technology which is known as adaptive understanding. And so the idea basically was that we merge human intelligence with artificial intelligence. So wherever our machines are not confident enough to make a call, then we switch over and we switch in real time. So the control goes to a human agent, which tells us that, okay, this is the intent, these are the entities, this is what the customer is talking about, and this information is supplied back to the machine learning loop. We feed it back into the loop, and then the next steps are carried forward. So this was a patent proprietary tool, and it was a key marketing differentiator in the early 2000s. Then during the last decade, so in early 2014, Interactions acquired the AT&T research department, and we licensed IBM Watson program, and that's how the entire artificial intelligence, machine learning models, and all that intelligence was integrated into the previously adaptive understanding, making the systems more advanced and more commercially successful. Then during the last couple of years, we built our own the entire technology stack. You name anything that's related to conversational AI, and we have our own foundational models, our own technology stacks for that. And during the last couple of years, we are working towards really advanced technologies, such as WiDS, biometrics, redaction, social. I'll introduce some of these concepts towards the end of the talk. So basically, the idea for today's talk is just to broadly define what a conversational AI system is. Before joining Interactions, even my understanding was that we have to worry about, we have to design a system which can either chit chat, or it could be a task oriented dialogue. So we design systems, we design domain specific systems. For example, you'll design something to do airline reservation, or you will design something for ordering into the food services. But there are lots and lots of technologies that are integrated together to make a successful conversational AI system. So that's why I thought it would be good to share what we actually mean by a conversational AI systems. Basically, what are the four main important components, and then just to give an idea of how much of technical depth is required, and that it's not just building a simple machine learning based system or building an AI system. It's as science related concept as an art related concept, and I've included one simple case study to demonstrate that fact. And then towards the end, I will talk about what are the future directions that we are working towards, and what are still very important and interesting challenges that are associated with this field. And so the idea is not just to define and build a base of what conversational AI systems are, but also to hopefully leave the audience with, that, oh, these are the interesting application areas, or these are the interesting problems that industry is still solving towards. And in case somebody is interested, please feel free to get in touch with me, and we'll take things forward. So let's actually start. So, what is a conversational AI system? Um, Broadly speaking, conversational AI system is a collection of all the tools and technologies that allow a computer or a virtual agent to interact with a human being and mimic like a human conversation. So this interaction, the key part is that humans interact using a natural language, and the computer gets that input from the human in a natural language. This natural language could be text, could be a voice signal. So it has to take in the command, take in the request, understand it, figure out what next action steps are to be taken, carry out the next action steps, and if it's information providing, then provide the information and accomplish the task. So that's actually what a conversational AI system is. And this is slightly different from the kind of chatbot interactions we do. So most of us, I believe, use bookmyshow.com for booking movie reservations, or when we go to the bank website sites. So we get a chatbot as to how may I help you type of questions, right? So how is conversational AI different from those kind of systems? There's a huge difference. So chatbots essentially are designed with very specialized and specific domains. And it's kind of very much rule based. If this is what the user responds, this is what the system response should be. And we are basically talking about chat based interaction. That's why the term chatbot. So some of the common conversational AI systems that we normally use are like we have Alexa at home. So we just ask Alexa, what is the temperature outside? What is the news? Can you play this song for me? So this is little more than a chatbot. When I ask Alexa to play a song for me, I am giving it, I have a task at hand. I'm giving it some instruction. It has to look into the database, search for that song, and then play that song. Same goes for Siri or Google Maps. Like we ask the Google Maps, we just give it a voice command. Please share instructions for going back home, wherever we are currently. So Siri, Alexa, other than interactions, obviously, are some of the examples where in common day usage, we are using a conversational AI system, right? So how do we build such conversational AI systems? What are the four key important components of building such AI system? That's what is coming next. So um, in general, this is how a conversational AI system works. And like I said, in comparison to a normal text-based chatbot system, the key important factor for a conversational AI system is that the user can interact using any different modality. I can give instruction through like a Wi-Fi medium. When I say Alexa, play this song for me, or I am calling some customer care number, then I'm giving the instructions. I'm interacting with the system using my voice, using speech signals. The first one is Wi-Fi, like you talk with Alexa. Then the mobile is you are talking to a customer care thing. Third one is like a chat. You are interacting through Facebook Messenger. You are sending an SMS. So there are different modalities with which the speaker is, with which the end user is interacting with the system. So in case of voice-based systems, when we are speaking out the instructions, we are communicating through voice. The very first step is that the system needs to transcribe or convert this voice signal into the text signal, and that's what an ASR module typically does. It's an automatic speech recognition system. So the main objective of ASR is, I for example, if I say play this song for me, so ASR will convert the voice signal into text, and play this song for me is what goes into the input into the NLU engine. The NLU engine has to figure out what is the user intent. Is it asking for weather? Is it booking a cab? Is it playing a song? Is it reading out the important news? And what are the entities, if there are any? For example, if I'm just saying play a song, that's incomplete instruction. If I say play classic Devanand hits, then I've included an entity which is like specific to Devanand, right? So NLU system interprets the meaning, extracts out the information, and sends it to a dialogue manager. And dialogue manager is what is actually responsible for that. Okay, this is what the user wants, this is the intent, these are the level of entities. Now dialogue engine orchestrates, decides, or based on the dialogue policy, that what should be the next response. Do I need further information, or how? And then dialogue manager actually produces some kind of structured information or generates a response, which then goes to the NLG system. And the NLG system responds back saying that the current temperature is 44 degrees, playing Devanand hits from this soundtrack. It just gives us this message and plays the song or fulfills the task. So essentially these are the four main components. I'll just go through in a high, I'll just give a high level overview for each one of these components. And in the center, this round circle with these two arrows is all our deep learning, machine learning models, because each one of these components, for each one of these components, we have specialized dedicated models that work and give us the result. So to start with, in any case, if you're feeling that I am going fast or I need to clarify one or more terms, please feel free to drop in a message, and I'll try and answer it right now. So why do we need actually an ASR system? So the objective of ASR system essentially is just to convert speech to text, nothing else. No interpretation, no knowing that, okay, this is what the user means, nothing of that sort. The only objective of designing, of having an automatic speech recognition system is to convert speech signals into text. And the reason why this is important is because if we chat, or if we are using some specialized interfaces to give commands to the user, we restrict the number of users who can use that system. But if you convert it to speech, that the system can accept simple speech signals, then anybody in the world can use this system. So it enhances, it makes the system more flexible and more user friendly, because any group of users can use the system now, right? And so essentially how things happen is there are various kinds and various basically we have two kinds of ASR models. So one is acoustic models, which are responsible of for getting, so the input is the speech signal. The speech signal is divided into frames. For each frame we kind of decide what the phoneme sequence is, and then those phoneme sequence are given to the language model to construct words and then sentences. So the ASR module basically gets divided into two types of models: the acoustic models and language models. Right, and the most common example is normally when you, if you are doing some course on Coursera, or you are watching some normally Amazon, some kind of shows on Amazon Prime or Netflix. So along with the movie, you get to see the transcript on the bottom. So these are some of the commonly seen examples of automatic speech recognition system, and depending upon how accurately the ASR system is performing, the NLU system will interpret, figure out the intent, and everything else. So it's really very important that the ASR system gives us accurate transcription and accurate speech to text conversions. So the next step is natural language understanding. And so at a high level overview, when we say that, okay, we are giving some command to Alexa to ask for what is the weather outside, it's a very simple information seeking thing, not really a example of a conversational AI system. But if you think like the way normally if you are placing an order through Swiggy or Zomato, you are interacting it through a chatbot. But think about if there's something wrong with my laptop and I need to call Apple customer care or HP customer care or Dell customer care, we normally interact with humans at the other end, right? and it and most of the times the very first thing is we have to wait for longer and longer duration for the for human agents to be free. And most of the time we hear this line that all our customer care executives are busy, either please hold or call back after some time. So that's where conversational AI systems are extremely and essentially helpful. And if we have to design a conversational system which can take in let's talk about a very simple food services domain, right? So what are the possible use cases there? I might be calling up to place an order, I might be calling up to update an order, I might be calling up to cancel the order, or I might be calling up to find out the status of the order, right? So in all these cases, the scenario where I'm calling up and the user is interacting with and saying, um, um, I want to order a pizza. So then what kind of pizza, what is the size, how many pizzas do you want? So it's an entire conversation just like we have with a human. And that's why the NLU component is not just simple intent recognition component. There are simple NLU components which are just the first case, which are simple, that it's a message routing decision making thing, or we are talking about the second case, which is fulfillment. So for example, in the first case, there is a change I don't recognize on my statement. So this is like you've identified some kind of discrepancy in your banking statement, and then we are deciding whether it is a technical support kind of thing. So we'll route it to the technical support department, otherwise we'll route it to the billing department, or we'll route it to the order taking department. So the first step is basically a simple classification, and my NLU model would just take in the text generated from the ASR, feed it to the classification module, get the classification module, and accordingly take up the next call. That okay, if this is a billing question, we are forwarding the call to the billing department, and everything is an automated version. In the next case, for example, it's task fulfillment. So here, let's say we are making a call to say that I'm planning a trip to Jaipur, and I want a hotel reservation on this and this date, right? So when I say I'm planning a trip to Jaipur and I want hotel reservation done, um, if I do not specify the date, the system should ideally ask me what is the date. If I specify the date, just like in my previous example, I said that the start date is this, the end date is this, then the system should not ask for what the dates are. The system should ask for how many persons are there, and then the system should also might give once it gives me the options that okay, we have hotel A and this is the price, hotel B this is the price, hotel C this is the price. This is a dynamic conversation, right? So this is not just a simple rule based conversation that's happening. And so in this case, if this I like to make a reservation at the Hotel Commonwealth for January 29 for 2 nights. If this is the input that's generated, if this is what is the output of the ASR and input to the NLU system, the output of the NLU system is the entire set of intents and entity slots, all the information that's available in this. So the intent is to make reservation, and then the entities are property name is this, the date is this, the number of nights is this. But so this is what is happening right now. And then at the end, the more complex our conversation is, the higher and higher are the NLU components that are required. For example, I'd like a Soho burger with pickles and mayo and a big truffles, and oh, do you have any salads? And after that, or extending the previous example, once I've had a hotel reservation, I might ask what are the important events that are happening. So I'm shifting the intent, and I expect the system to be aware of, to keep track of what the previous context was, what the previous pieces of information was provided, and then accordingly update the information state and correspondingly carry on the conversation, right? So I included this example just to give you an idea that the designing of conversational systems, the NLU components, is not only identifying intents and entities, but it's really much more and more than that. um, but just to give you an example, so of an simple example of task fulfillment that we had on the previous slide. So this is the example of how we determine, this is a simple conversational flow for making a movie reservation. So the system welcomes the user and asks, how can I help you? The user says, I'd like to watch a movie. The system, the NLU engine, would figure out that okay, the intent is find a movie. The system then asks, what's the genre, what kind of movies do you like? And then the user responds back by saying it's a sci-fi. So the sci-fi, the intent now becomes finding a movie, and in addition to that, it's informed genre. So this is the current dialogue state. And sci-fi is the entity. Now, corresponding to this entity, there are various machine learning models that you can use to build this entire flow. So we kind of create knowledge graphs where we combine all the intents together and keep on deciding, okay, now we are in this part of the decision tree, and what kind of response should be determined next. So the system recommends, okay, Doctor Strange is running in the theaters, would you like to watch that? User says sounds good, so we affirm. Then we present user with more information that these are the appropriate timings. What time would you book a slot for? So then the user responds back by saying, book me a slot for this. Can I do something else? And then we close. So this is a very, very simple conversational flow. And this is where we are just focused with only the intents and the entity slots. And wherever the entity slots are missing, we ask the user feedback questions, collect the important pieces of information. So every task fulfillment would have that, okay, I require, for example, if you are booking a doctor's appointment, you would need date, time, both the things, doctor's name. So if you are missing in one of the important pieces of information, the system knows that if this is the intent, this is the task I want to accomplish, then these are the entity slots I want to fulfill. And accordingly, the flow is designed, and it's all dynamic because it's all based on the decision as to how the user is responding back. If you've only asked what genre do you like, and the user responds back saying, I like science fiction movies, and could you look in for Doctor Strange, then I would not search in the database for what science fiction movies are currently running in the theaters, because I have another piece of information. So it's really dynamic, and hence the kind of NLU systems that we want are also complex. Right. After this is what comes the dialogue manager. So the task of NLU engine actually is, so given the system says welcome to so and so theater, how can I help you today? The user says I'd like to watch a movie. The system determines the intent is find a movie. This much piece of information just for these two utterances, the system prompt and this user response as an utterance, just these two pairs with intent is this, and entity mentions or entity slots are this is what goes to the dialogue manager. And dialogue manager is actually where we design the entire conversational flow. You can think of that as an entire flow chart. Before we build a software or an algorithm, we kind of build the flow chart where we discuss, where we keep in mind and make sure that we've covered all the edge cases and everything. So dialogue manager is what orchestrates and interacts or integrates with different APIs and databases depending upon the kind of the task that's required, and figures out or decides what is the next system action that's required. So for example, if we talk about Alexa, play this song for me, Alexa goes first, identifies what the intent is. Okay, the intent is to play song, and this is either the title track name or the singer name. And then once it has the complete set of information, then the dialogue manager accesses its database, picks up a song, and plays that song for the user. Right. So all that, deciding upon what should be the next response. If we have to provide any kind of information, then what kind of information needs to be provided, all that is what is orchestrated by the dialogue manager. And of course there are, you can design a dialogue manager in various ways. So one is using a simple procedural language. So you think of it like you've designed a flow chart and you're converting into a program. You're deciding if this is the situation, define all your rules, right? So if this is the rule, then this is the next step. If this is the rule, then this is the next step. Another possibility is what we call as knowledge graph based dialogue manager. So wherein we just construct everything. For example, if I am designing a conversational AI system for something like a Burger King or a Pizza Hut, I know the entire catalog. I know if we are talking about a pizza, I need what are the different sizes. I know what are the different kinds of toppings that are available. I know what option of breads I have to ask. It's a thin crust or a thick crust, what type of pizza. So the entire thing, and you can imagine that it's like a catalog, and we can build the entire something like a decision tree, that if this is the case, then what are the various alternatives, what things are optional, what things are mandatory. And accordingly we design a dialogue manager according to that. So wherever we are in the conversational, like we've asked for the genre of the movie, we've fixed the movie name, now we are talking about the shows. We fixed the theater and now we are talking about the shows. So depending upon where in the path in that knowledge graph we are, we know what are the next action steps to be carried out, and if we need further information, then what are the questions to be asked from the user. So there are various ways we can design and work with dialogue manager, but essentially it's one of the key components which decides the next step and the next action items to be carried on. And last but not the least, so dialogue manager would say that, okay, I found the song, it would bring the song, start, and before it starts playing into the playlist, Alexa responds back by saying that, playing this song, or we respond back by saying that I am reserving tickets for Doctor Strange in this movie theater at this time, kindly confirm. So we need affirmation from the user that we are carrying out so and so action, can you please confirm. So and at times it's like you are interacting. The customer first says, I want to order a thin crust pizza, I want these toppings. Then he says, no, I don't want mushroom in the topping, I just want simple onion cheese pizza. So here within the conversation, first some kind of information was provided and then the user updated the information. So before we finally place, we would like user to affirm that, okay, this is what you are ordering right now. So dialogue manager would give us that information, and the NLG system is then responsible for giving it a proper surface realization. For example, if I have to proceed further, if we are making some payment and we have to ask for a CVV number, there is a certain way that I'm going to ask a CVV number. If I have to ask customer's last name to confirm the order or to confirm the rest of the details, I will say, can you please say and spell your first name? If I have to ask the CVV number, I will not say, can you please spell your CVV number? And so natural language generation is another key and important component of a system, because this system is what is responsible for generating the end response back to the user. And most of the times we have, broadly speaking, two options. One is a template based generation. So I have quantity is 2 pizza, and then filling type is let's say I want cheese onion capsicum pizza. So template based would be that every time a customer pays an order, we would say, you've ordered 2 pizzas, you've ordered 2 medium sized pizzas, and the total billing amount is this much, right? So that's one way. Another way is depending upon where we are in the conversation, at times depending upon the modality. So in voice based systems, mostly it's like and depending upon the user. So there might be situations where somebody says like, my mom wishes to travel to so and so place and I'm looking for this but I could not find this, so can you find a hotel? So all the previous information, my mom is interested in going here and there, is irrelevant. So the system has to understand and pick out that the relevant piece of information is, you are looking for hotel reservations in a place, let's say Haridwar or Rishikesh, right? And so dates. So it's like, so we have a full context and we have to extract out important pieces of information. So in that case, template based generations are really not that successful, and we work towards neural sequence generation based systems where we train LSTM based models or recently transformer based models to figure out and extract important pieces and return it back to the user, prompt it back to the user saying that, okay, we are looking for hotel reservation in Rishikesh for so and so date. Is this what you are looking for? Once the user confirms, we proceed ahead and go back. So essentially, these are the four main components. And just to give you a brief glimpse about one of the situations, so I thought that this would be an interesting use case. So this is how, in general, we all the enterprise level systems design a conversational system. So if you are designing a system for Nike or Pizza Hut or Burger King or Domino's, so essentially the business unit approaches the design team, and the way we discuss is the business team shares the requirements with the design team. They prepare a functional requirement document. These transactions happen back and forth. So think of it like the software. For the software development also, we build the entire cycle, right? And this has to be done for every business use case. I'm placing an order, you'll build this thing. Returning an order, you'll have a separate use case. Then for finding out the status updates, you will have another use case. And so this is how it's normally done for each and every client, specifically and individually, and everything begins from scratch. So the problem with some of these systems actually is that every time if you are following this repetitive process, it's kind of highly repetitive. So, and it doesn't really change very much if you are thinking of the same thing. For example, for all the food services, be it Pizza Hut, be it Burger King, be it Sagar Ratna or any South Indian based firm, based business unit, so we are following kind of repeatedly the same thing, and not just across domain. It's like asking the same thing. There are many variations that could be used. And this is just to give you an example, uh, I'm not sure this is how readable this is. So this is just a conversational flow or a happy path for finding out the account balance. And here the interaction starts with, again, the system welcoming the user. The user saying, I want to find out my current balance. And the system, in order to authenticate the user, starts by asking, can I have your account number, please? And so if you're designing, most of the time, if a naive user is designing a conversational system, they would be designing it using, can I get your account number, please? But on the right hand side, you can see many different variations for the same. Please share the account number, for which you find out the account balance. In order to share the account balance, I need to know your membership account number first. Please share the same. In order to look up for, so these are all the different variations. And if we are every time asking, can I get your account number, please, it sounds really very monotonic, and it doesn't really sound that as if we are having a human conversation, right? There should be some kind of variations that makes us decide that, oh wow, we are talking to a conversational AI system. Plus, the user would also have the feeling that he's not talking to a machine and getting back the same response 24/7 every time you call. So the key questions in this, the entire automation of the design process is, first, how do you think we can design this automation of the conversational flow process? Because for every domain, the requirements would be different. Across domains, some things might be simpler, some things might not be simpler. And the most important thing is, it's really an art to design, um, these system prompts. So these are all like, what's your membership account number, please share. The more carefully these prompts are designed, the more impact and the more better customer experience the user has. So how can we design, how can we automate this process, and how can we provide a framework that would suggest the different variations? So if the user is working on and saying that, I want to ask, yeah, last name, or please share your last name, then instead of just using that prompt, please share your last name, how can we decide and how can we give users the various linguistic variations that are there, right? So these are some of the key questions that we have to consider, keeping in mind that how do we design a conversational system, right? So one thing that we explored, that the project that we did was, we collected conversational logs from because we've been designing this system, like I said, from 2004, and so we generate billions of logs. So we have lots and lots of conversational data. So what can we learn from those conversational logs? Because not all the intents, not all the entities are equally relevant. So the intent distribution is not like a uniform distribution that all the intents are equally important. It follows like a normal distribution, or most of the time it follows a skewed distribution. Some of the intents are very, very popular. They are very commonly used. Some are not so commonly used. So how do we consider designing such a system, and how can we leverage whatever systems we've designed in the past? So I'll skip these two slides in the interest of time. So what we did was we essentially collected prompts from different verticals, like from finance domain, from retail and hospitality domain, from food services domain. So we collected the set of prompts from the conversational history, because we wanted to pick prompts that are most commonly used. We created an index. We define a consistent common vocabulary. For example, in one application, let's say in Pizza Hut, it might be can I have your first name, please? In Burger King, it could be, please say and spell your first name, please. And then in Pizza Hut, we are calling it as capture first name, the intent. But for Burger King, we are calling it as ask first name. So the same intent, the same purpose, the same kind of questions, but they are being labeled differently. So we defined a consistent vocabulary, created an elastic search based system with different search attributes. So the entire prompt itself is one attribute. So if I am saying please share your first name, if I give that as a query, I should get all the semantically similar variations for that. So that prompt itself was one attribute, the intent was another attribute, the entities was the third attribute. And then we provided the system to the design team, so that whenever they are working on designing the entire conversational flow, they can just feed in and look at what kind of prompts have been designed in the past, get an idea from there. Or this is like an auto suggestive tool. So when we write an email, if you start typing looking forward, and the Google gives you a suggestion as to how you can complete the sentences. So in the similar way, this NLG system returns back the system responses, that is this what you're looking for. So this is like a suggestive tool that's there, right? So this is one use case, just to give an idea of how complex things are, and how different complex things you have to take care of when you're designing such a system. And um, so up till now is what I've talked about, what are the key important conversational systems, and essentially how things are working in general everywhere. Now, some of the important research questions that the conversational AI systems are moving towards, I'll share some of the important research questions with you. So the first thing is omni-channel capability. So to give you an example, um, so with omni-channel capability, what we are talking about is that I started my conversation through, let's say let's say a voice-based thing. So maybe I was talking on the phone and I want to order a bouquet for my friend. So I am talking about the pricing, and I'm talking about how much time would it take, and whether delivery is possible or not. And once my basic queries are satisfied, let's say I call Ferns and Petals, and so once it says that yes, we would deliver to so and so address, and we have these are the options, and this is what the price range would be, and things match, then maybe I would like to have, get images of the flowers. Maybe I want to see the bouquet. So I might ask them to switch from simple call to a video call, so that they can show me, or to a chat based conversation where they send me images of the different bouquets. I select, and then we negotiate on the deal. So that's what essentially omni-channel capability is, that if I start my conversation from a phone call, I can switch it to a chat-based modality. I can switch it to, or if I started my conversation from a chat-based thing, I can switch it to a mobile. And so essentially the models, the intent recognition, the information state, everything is shared across different channels. So if I'm switching from a voice based modality to chess to a chat based modality, it's not that I have to start everything from scratch. Wherever I was with the voice based system, I will do a live switch, and the entire information state, whatever information I have provided, that this is the delivery address, this is on this date, this time I want the flowers to be delivered, all those pieces of information should be transferred from one channel to the next channel. So how successfully can these systems build, and how successfully can we place these orders, how quickly can we switch from one channel to another channel? So that's one of the interesting research threads that we are working on. So that's what is called as an omni-channel capability. And also what happens is, like I said, in the beginning, adaptive understanding is one of our important differentiators. So what happens is, we train our AI systems that, okay, for this intent, these are the training data. So we collect training data over a period of time, and we train our models. But of course there are still noise there, the system still makes mistakes. So whenever our machine learning system is not very confident, so we have our confidence thresholds. So if the system is not very confident that this is the intent, then it gets, in real time, it gets transferred to a live agent. The live agent sends the information back to the NLU engine, to the dialogue manager, and then we carry on the regular process. So now the question comes, currently we are running a manual feedback mechanism and training process. So maybe every week, every fortnight, we would collect fresh training data pair, do some error analysis, retrain our systems, and then improvise on the existing models. But since we are working and we are interacting, so what can we learn automatically from these conversations? How do we improvise on the existing model? And what kind of analytics can we learn? So if we are building a system for Pizza Hut, for a food services, then what kind of insights can we provide? Can we say that, okay, these, in this area, these items are mostly on sale, in this area, these are the kind of products that are on sale, these are the specific designs that are highly in demand. If you are upselling, that we are offering 1+1 and this is the deal, or we are offering bread and butter together, and so what kind of upsell strategies are more successful? So there are, I mean, you can imagine a domain and you can think of all the analytics that can be performed. So that's one very important research area that we are that the industry actually is looking towards. Then right now we said we use Asr systems to convert speech signals to words, and then we use NLU engine to convert and to understand and interpret what is the meaning behind what user is saying. So can we skip that? Can we learn to understand directly from the speech signal? Can we build models that are intelligent enough to do that? Another very interesting and close to my research area is zero-day modeling, which is, so normally when you think of designing conversational AI systems, the business teams interact. At times, the business units would provide their historical logs that we can use as a training data to generate the training data and train our systems. But what happens in case somebody decides to use a dialog flow, or somebody decides to use any do it yourself kind of a system, where the system says, okay, I will give the intents, I will define the intents, I will define the entity slots, but I want an intelligent enough system that I just define these systems and things work. So that's zero-day modeling without in the absence of data, in the absence of any kind of training data available and no historical logs, so can we build systems that are intelligent enough that they start working from the very first day? So that's kind of 0-day modeling or few shot learning scenarios that we are talking about. Then can we leverage, so right now maybe we have systems that are designed to converse in English to English, or we have systems that are designed from, let's say, English to Hindi or English to Spanish. But what happens if the user mixes English and Hindi together? At times just to trick the virtual agent, at times because he could not think of a better English word and he just mixed. So kind of, if it's kind of a code mix situation, then what would you do? How will the system learn and adapt? How will the system pick up that, okay, this is the next response that has to be done? So you have to build models that are trained with code mixing, and that are trained with multilingual data, and everything else. And another one is like, how can we redact sensitive information from a conversation in real time? So just to give you an example of 0-day modeling is, 0-day modeling essentially is that the company contacts us and says that, okay, we want to hire and use your platform. We will define our flows by ourselves. So we will define the intents, we will define the entities, and maybe we will give 1 to 5, we really don't know how many sample utterances they would provide. That, okay, for intent 1, these are the sample utterances. For intent 2, these are the sample utterances. So most likely between 1 to 5 or maximum 10 is how many samples they would provide. And with just 10 samples and the intent definition, there is no way you can train a decent machine learning algorithm, leave aside the deep learning systems, right? So there are two specific workarounds with this. So one is kind of a few shot intent and entity detection systems, and another is data augmentation. So with data augmentation, it's like you train a neural system based for a paraphrase. So you give it one sample sentence. For example, I'd like to order a pizza. You give this input. And so we are currently exploring two different options. One is from our conversational logs, we'll feed this as a query. We've created clusters. The query will find out the relevant cluster, and accordingly, based on either the number of samples that, okay, I want 10 samples that are similar to this, or I want to generate samples that are 90 or 95% similar to the query, and accordingly we generate more utterances appended to the set with the same intents, and basically enhance the size of the data set, so as we can create a reasonable training data set available for us. I think I am going over time, so I'll skip that, and I'll just talk about the redaction one. So redaction basically is, let's say you're calling and you want to find out the current account balance, or you're placing an order, you've shared the card number, and now you have to share the CVV number. So in these two cases, neither the card number nor the CVV number, because this is very secure private information. So none of this information should be stored in the database, none of it information. If things are going to a human agent, they should be transferred to a human agent. So this piece of information should be properly redacted. That means the agent or the database should just see star, star, star. They should not be able to hear this information. So that's essentially what redaction is. And there are various kinds of heuristics, model training that's happening, and it's really interesting problem, because think of this. So if instead of CVV number you start saying your telephone number, so CVV generally is a 3-digit, telephone is a bit longer, and zip code is another thing. We don't need to really redact the zip code, right? So you have to figure out where the customer is starting to speak sensitive information, and what type of information categorizes, authenticate, and mark everything. So these are some of the interesting problems that we are working on. In case anybody is interested in talking more about this or finding out more pieces of information, then I would be happy to do so.
Yeah, I hope I'm audible.
Yes.
Okay. Yeah, so we have few questions. Um, the first one is like, I'll just read it out for you. So mostly the NLU is neither decision tree or would be a random forest. Is it correct
No.
understanding, or we can use other classifications method also for the same?
Yes, so depending upon the complexity of the system you are designing, it could be a simple classifier. For example, if I'm designing a simple chatbot, I have a couple of intents, then all I need is design a multi-class classifier to figure out what is the intent, right? But if we are designing a complex and a dynamic conversational AI system, then we need little bit more than that, because we need to figure out the intents, we need to figure out the entities. So it's not necessary decision tree and random forest. You have there are situations where an SVM model also works best. So it again depends on the complexity. I would not restrict it to a very simple classifier.
Okay, so we have another question, like, what is most common technique used in NLU?
See, there is no most common technique because NLU incorporates a lot of things. So, most common technique is you have a piece of text, you will tokenize it, right? You will generate a vectorized representation, and then either you can feed that vectorized representation to your classifier model. So essentially the pipeline is like, you'll tokenize, you'll generate a vectorized representation, or you'll create an embedding representation, feed it to the classifier or the neural net as an input, and then generate the classifier output. So in general, that is the most common one. And again, it depends. So usually we have one classifier for intent, another classifier for entities, a third classifier for figuring out something else. So depends, but essentially it goes on like that. Dipti, you are speaking on mute. I think you're speaking
Okay,
on mute.
sorry. Yeah, so the next question is like, I would like to gain applied knowledge in the omni-channel and zero-day modeling area. What would be the best way? If you have any open position for intern research, would be great, a great step.
Sure, we do have open positions both for intern and full time. And should I share my email here on chat? I think I put it on the last slide, but I did not. I'll just share my email ID here. And to give an
Yes,
idea,
please share.
uh, here, Nidhi Arora at the rate interactions.com. And otherwise, so for omni channel, you have to first really understand it, how the things work in first channel, right? Once you understand how things are working well in first channel, how the dialogue manager works, how intent entity recognition works, how the various components interact with one another, I would say you should start with that and then move towards omni channel, because it's like a child, learns to walk first and then starts running. So you need to have first the single channel understanding. And for 0 day modeling, I would recommend that you start reading the literature for few short work, but definitely interact with me. We have open positions both for intern and full time, and we can definitely work something out.
Okay, that's really great. We have another question like, what is the most important parameter for the NLU system? Models accuracy or recall or precision?
Mostly it's accuracy, because we want to accurately predict out that what the user has said, we've correctly captured that. So in terms of intent recognition, there is lesser intuitively, if you think about it. I am asking the system to tell me what is the temperature outside, right? I want the system to correctly understand what that is. There's no concept of a recall here. It's not that these are the five possible correct alternatives that the system should pick up. The system is picking up two correct or three correct or five correct. That's where you use recall. Precision is how many have you correctly identified. So none of these, it's basically accuracy only.
Okay. Next question we have, it is regarding the build generic system. Okay. So if we want to build generic system, is there any open source module available for the same which is already uses existing common sense knowledge?
No, that's a good question, and that's where we are still researching, and it's still in theoretical phases. But none of the commercial systems are actually generic AI. We are still building systems specific to one particular domain and catered towards. We have generalized now. We no longer build, systems specific to every use case scenario. We've generalized slightly, but generic AI systems that are, applicable across general domains, we are still far from that. It's an interesting, but it's still in infancy stage, I would say. Though if you are interested, you should read about the recent there is something which is known as prompting based solutions. So after transformers, this is something that's recent in the NLU literature that you should read. They claim that this works for 0 day setting, or this the models are generalized enough. You give 2 3 4 examples and the system learns from those examples and would give you. But you have to see theoretically, academic publications, it's easier to talk about these things, but commercially systems, no, they are not.
Yeah, so I mean, that was really great. And that was really a wonderful session, dear ma'am. And I'm sure all of our participants must have got an deep insight about conversational AI, and I hope this talk will definitely ignite our participant to explore the conversational AI domain.
I hope so. So I've left my email ID in the chat. I don't know whether it's visible to everyone or not. So yeah, feel free in case anyone has any doubt, any question, would want to pursue something in this field. I would be happy to share my knowledge with you all. Thank you.
Yeah, sure. I will share the mail ID and even I'll share the LinkedIn Connect as well, so
Sure,
that if at all participant wants to connect, they can directly reach you
sure,
out.
sure. My pleasure. Thank you.
Yeah. Okay, ma'am. Thank you so much for giving your precious time and delivering such a wonderful sharing your knowledge on conversational AI. Thank you. So after this technical talk, now we are going to move ahead with data challenge round 2. Hi Puja, welcome back.
Hi Deepti, can you hear me?
So yeah, it's time for going to announce the winners, as well as we are just going to start with the data challenge to round two. So we have Puja here, which will just brief you about the same. Yeah, Puja, over to you.
Cool, guys. So, as I've mentioned before, also that we have shortlisted 25 teams, and to be precise, not 25, 24 teams who have, like scored 50% of the marks in the quiz itself. So now those 25 to 24 teams would be receiving email from our side, which would be consisting of an Excel file along with the data sets and the questions which you need to answer. And what you need to do out of it is don't do any, like, it would be in view mode. So what you can do is you can copy it on your on your drive, or you can download the file as a CSV and start doing the analysis. Once you complete your analysis, you need to present, like, consolidate all of the answers of the questions in one PDF and send it to us on the mentioned mail address, that is puja@henryhaven.com. The time for the same is 45 minutes. So the moment you receive the email, which you would be receiving in the next 15 minutes, post then you will be having 45 minutes to submit your answers. After submitting the answers, we will evaluate them in an hour, and at around 4 or 5 we would be saying, giving you the results of round 2. Post, like, and in this round we would be selecting 15 teams for round 3, and then for the data sets of round 3 would be shared with you all like in the evening itself, and you would be having around 12 to 14 hours to solve it and submit the results to us, like submit your solutions to us by tomorrow noon. So that is what the whole data challenge will look like, and we will announce the winner of the round 3 in, like, at the closing ceremony of this WIDS, and maybe Deepti would be able to give you more insights about it. So yeah, that is it about this round 2. If you have any questions, you can shoot those questions in the chat itself. Do we have any questions? No. So I guess, Dipti, we can, like, we will be sending the mails at 2:15, and 3 o'clock the event will be over. Like, the time would be there for submitting the answers.
Yeah, Puja, that's fine.
All right.
If anybody
Awesome,
is
guys.
having any question, you can drop it in the chat box. Okay, Puja, so we'll just share that questions for round 2, and
Yes.
then let's catch up at around 3 to 3:15 so that we can declare the winners and we can move on to round 3.
Yeah. So the results will be declared, like, post, they would be submitting their answers. So it would be at around, like, 3 o'clock is the time they would be submitting their answers. So after evaluation, maybe at 4 or 4:30, we can declare the results for round 2.
Okay.
All right. All right, guys, all the very best for round two. And please wait for 10 minutes and you would be receiving a mail sharp at 2:50. Please wait for 10 minutes and you will be receiving a mail sharp at 2:50.
Yeah, so let's catch you all at 3 to 3:15.
Okay.
Yeah. Okay, Pooja, then thank you. Thank you for joining. And participants, you'll be receiving the mail shortly. Thank you.
Yeah. Bye.
So we have already shared the mail for round 2. We'll be back at round 4. We'll share the live link for round 2 winner announcement and round 3 details. And we'll see you all for tomorrow at 10:30 for the technical talks. Thank you.